I can justify each step in solving an equation or inequality. Here's what you need to know. When you are adding the same thing to both sides, that's called the addition property. And here's an example. We have x minus 4 equals 11. We need to add 4 to both sides to solve it to get x equals 15. So that's an example of the addition property. We added 4 to both sides. When you subtract the same thing from both sides, that's called the subtraction property. When you multiply both sides by the same thing, that's called the multiplication property. When you divide both sides by the same thing, that is the division property. Hopefully you're seeing a pattern here. When you multiply everything inside parentheses by the coefficient that's outside the parentheses, that's called the distributive property. So in this example right here, the 4 on the outside is being distributed or multiplied to the x and to the 3. That's called the distributive property. And one final justification. When you're adding or subtracting terms that have the same variables and the same exponent, that's called combining like terms. So in this example, we have a 4x plus 5 more x's. I can combine those terms together to make 9x because they have the same variable and they both have the same exponent, which would be the power of 1. When you have an equation with an equal sign, these are called properties of equality. And when you have an inequality, like in this example right here, or this example right here, they're called properties of order. Here are a couple more tips. These properties are used when we're solving equations or inequalities. When you're solving equations or inequalities, you're trying to figure out what number value the variable can be. In order to solve for a variable, you need to get the variable alone on one side of your equation or inequality. That's called isolating the variable. You're getting it all by itself. In order to isolate the variable, you have to undo everything that's being done to your variable. To undo the things being done to the variable, you're going to do something called the inverse operation. That means you do the opposite operation. In the first example right here, x was being subtracted by 4. So to do the opposite of that, or the inverse operation, we add 4 to both sides. That resulted in isolating the variable x, or getting x all by itself. Here's an example of how to use justifications to explain your steps. Which justification explains the transformation between line 1 and line 2? So line 1, line 2 is over here. In other words, how do you get to line 2? We're going to go see what happened to both sides in order to produce line 2. I see that I have subtracted 4 from both sides of this inequality to result in line 2. The 4 was being added to n at the beginning, so the inverse operation would be to subtract 4 from both sides. So my justification was the subtraction property of order, because this is an inequality, so that makes it a property of order. We subtracted 4 on both sides to get to our step, and it's an inequality, so we call it the property of order. Go ahead and pause, try this one, and then we'll check it together. Which justification explains the transformation between line 1 and line 2? Or how do you get from line 1 down to line 2? We're going to look and see what happened. We're seeing that the variable n is being multiplied by 5 at the beginning. The inverse operation of multiplying by 5 is to divide both sides by 5. That means our justification is the division property of equality. We divided both sides by 5. It's the division property. It's a property of equality because we're dealing with an equation. Equation, equality. If you want more on this topic, make sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.